All right, we are going to continue parent functions and transformations. Our last video stopped with example 4. We've got 2 more examples, but I wanted to kind of split it up a little bit. So we're going to start here with example 5. Use a graphing calculator to graph g of x equals negative absolute value of x plus 5 and then the minus 3 on the end, and its parent function, then describe the transformations. So this has a whole lot more going on than we were looking at with examples 1 through 4, which is yet another reason I wanted to kind of split it up for you. But first, let's start with graphing our parent function. If you remember back to the previous part of this lesson, the previous video, our parent function is absolute value because of these absolute value bars. We start at the origin. We have a slope of 1 on the right side. We have a slope of negative 1 on the left side. And that's going to make our v. So let's get us a line there, if I can get to the right spot. All right. So there's our v for our absolute value function. And now we are going to, I'm going to put this in my calculator and get some points to plug in and plot on this new graph, this g of x. Let me go ahead and label my f of x before I forget. F of x equals the absolute value of x. All right, so g of x we'll do in red. And like I said, I'm going to go ahead and plug this into my calculator, and you can use Desmos.com. There's an app on your phone. There's a website. If you don't have a calculator at home that graphs, or you can just wait until you get to class if you need to use that for some reason. We'll be doing our homework assignments in class, so you'll have these calculators there for you. The first point that I'm going to plot is going to be -7, -5. So let's go over 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4, 5. And then we're going to look at -6, -4, -5, -3, -4, -4, -3, -5. And I'm going to go ahead and just stop there. And we will draw a line to create, or 2 lines to create our absolute value function here. All right, so if this is our g of x function, we'll write that down. That's g of x equals negative absolute value of x plus 5 and then minus 3. And like I said, there's several things going on here, and you can kind of tell by the graph what all's happening. If, for one, it's flipped upside down. So we call that a reflection. It is a reflection across the x-axis. So we have our absolute value. G of x is a reflection across the x-axis. So that's the first thing. And the first thing, we're going to go left to right. The first thing comes from the first thing listed. The next 2 things, and I just said we're going to go left to right, the next 2 things are usually flipped back and forth. The order of those doesn't necessarily matter, but we are moving left and we are moving down if we're looking at the vertex. Remember, the vertex is just the point where it changes direction there. So from the origin, I'm going left and I'm going down. Well, I'm going left. If I count on my graph, 1, 2, 3, 4, 5. And then I'm going down 1, 2, 3. Well, my left 5 comes from right here. Something you may notice is that it says plus 5. But if I were to take that x plus 5 and set that equal to 0 and solve by subtracting 5 from each side, I'm going to get x is equal to -5. That's where I get the -5 there, left. So negative shows me a left direction, left 5. Now, on the end here, I can just eliminate all of this and say -3, so that tells me it's going to move down 3. So we have reflection across the x-axis and a translation down 3 units and left 5 units from the parent function. So let's go ahead and highlight everything that is needed. We have our parent function and its label, our new function and its label, and then we have our description of all 3 of those transformations there. And don't forget, make sure that you highlight everything possible from your answer. Okay, so then now let's move on to example 6. These will probably be some of the shortest notes you have just because it's the second portion of the section. The table shows the height, y, of a dirt bike, x seconds after jumping off a ramp. What type of function can you use to model the data? Estimate the height after 1.75 seconds. Well, if we look at our table, it's going to be kind of hard to tell what function we're looking at or what type of function we're looking at. So what we are going to do is look at the calculator, and again, calculators in class are going to be a lot more beneficial than the calculators on the internet. So to determine what type of function you can use, I'm not going to make you search through that table and figure that out, but give me just a second and I will get a calculator for you that will help us figure out what kind of function this is going to be. Okay, so here we go. Here's our calculator, and from our home screen, we are going to put this into list and spreadsheets. So here's add list and spreadsheets. Make sure that at the top you put an X and a Y. I know you did this several times with Coach Montalvo or with Miss Hargis. Or wherever you came from in Algebra 1. I know you probably did this a lot, so just a little refresher course. And then we are going to put all of our x's in this first column, so 0, 0.5, 1, 1.5, and 2. And then in the y column, we have 8, 20, 24, 20, and 8. Now, if you notice, and first of all, make sure right here, after you plug in that 8, make sure you go ahead and enter down to that blank spot. But if you notice right here in this Y column, there is a pattern. It starts low, goes up to a high point, and then goes back down. So it could be one of two things. Could probably be, it's not going to be linear, it's not going to be constant. It could be either absolute value or quadratic. We have everything positive, it goes up, it goes down. So those are some telltale signs there. But from here, we are going to go to menu. We are going to look at our data, and we're going to do a quick graph. So number 9. Let me scoot my calculator over here some so we can see everything. And this is the screen that you're going to get. So my calculator looks a little different. You can see the whole keypad here, and then my screen is all right here, in case you were wondering. But you have to change. So we're going to click here, and we're going to change that to X. See, my numbers move, my dots are moving, and then I have to click over here and change that to Y. Now I have a graph. So you can analyze that and see what you think. Another thing you can do that's going to help you, and we're going to need to do this anyway, we're going to go to menu, and we are going to go to analyze and regression. Now, there's not an absolute value regression, but there is a quadratic regression. So we're going to click show quadratic, and lo and behold, it matches up perfectly. So this is going to be a quadratic function. Now then, what we also need to do is we need to write down this little function right here. Now, if you're wondering, the way I moved that, watch my pointer as it goes over that equation. See the little hand? If you'll hold down Usually on yours, the hand will close, and then you can move it to wherever you need to. So that is going to be negative 16x squared plus 32x plus 8. And we are going to write that right here. So we have g of x equals negative 16x squared plus 32x plus 8. So let's look back and see what questions are asked, what we've answered, and what we have left to answer. And it says, what type of function can you use to model the data? Well, that's the quadratic function, and we wrote down what the actual rule was for the function. So question 1 is answered, and we're going to use both of these for the answer of that first question there. Now, it says estimate the height after 1.75 seconds. So what we are going to do, we're estimating the height, we're estimating y, we're given 1.75 seconds. So we can plug that in. So we have g of x equals negative 16 times 1.75 squared plus 32 times 1.75, and then plus 8. And guess who already messed up? That would be your teacher. Instead of g of x right there, we are going to have g of 1.75 right there. That just shows that we're plugging in our 1.75. Now, on your calculator, so we'll go back over here to our calculator. Let's go to the home screen, and then just go to calculate, or you can press this little button that's down here, and we're just going to type that in. Let me make sure that we wrote this down correctly. We did. There's the negative. So let's type that in. Negative 16. Make sure that you open your parentheses. Oh, you know what I did? I pressed minus. Make sure you grab a negative right there, not a minus. 16. I was trying to use my keyboard instead of using the keypad of the calculator. 1.75. Close your parentheses. Squared plus 32, open, 1.75, close, plus 8. And if we press enter, we get 15. So let's go back over here, and we can write down that g of 1.75 is equal to 15. So if that's 1.75 seconds, then that is 15 feet. So the question said, estimate the height after 1.75 seconds, and we are going to say, after 1.75 seconds, the height of the bike is about 15 feet. So we will highlight that as well. Now, I know your big question is, we did a lot of that on the calculator, so do we have to show the work on our paper? Absolutely. You must show all of your work. If there is no work shown, I am going to assume that you have guessed. And once we get to test corrections, you will be much more aware of that than you are on your homework assignment. So if there's any work to be shown at all, then make sure you show it, whether you're putting it in the calculator or not. Just like this right here, we put that row in the calculator, but it's written there as well. So that's the work that is to be shown there. All right, that is example 6. That totally finishes up section 1.2.